Class 10. Subject Science, Physics. Chapter 9. Light, Reflection and Refraction. Topics to be learned in this video: lens formula and magnification and power of a lens. Lens formula and magnification. Formula for spherical lenses gives the relationship between object distance u, image distance v, and the focal length f. The lens formula is expressed as 1 upon v minus 1 upon u is equal to 1 upon f. The lens formula is general and is valid in all situations for any spherical lens. The magnification m produced by a lens is similar to that for spherical mirrors. It is the ratio of the height of the image h dash and the height of the object h. M is equal to height of the image upon height of the object is equal to h dash upon h. Magnification is also related to the object distance u and the image distance v. Magnification m is equal to h dash upon h is equal to v upon u. Let's take some example. A concave lens has focal length of 15 centimeters. At what distance should the object from the lens be placed so that it forms an image at 10 centimeters from the lens? Also, find the magnification produced by the lens. Solution: a concave lens always forms a virtual, erect image on the same side of the object. Image distance v is equal to minus 10 centimeter. Focal length f is equal to minus 15 centimeter. Now we find object distance u. Since lens formula 1 upon v minus 1 upon u is equal to 1 upon f, or 1 upon u is equal to 1 upon v minus 1 upon f, putting the given value 1 upon u is equal to 1 upon minus 10 minus 1 upon minus 15 is equal to minus 1 upon 10 plus 1 upon 15. After solving, 1 upon u is equal to minus 3 plus 2 upon 30 is equal to 1 upon minus 30. Or u is equal to minus 30 centimeter. Thus the object distance is 30 centimeter. Magnification m is equal to v upon u. M is equal to minus 10 upon minus 30 is equal to plus 0.33. The positive sign shows that the image is erect and virtual. The image is 1/3 of the size of the object. Let's take another example. A 2.0 centimeters tall object is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeters. The distance of the object from the lens is 15 centimeters. Find the nature, position and size of the image. Also find its magnification. Solution: height of the object h is equal to plus 2 centimeter. Focal length f is equal to plus 10 centimeter. Object distance u is equal to minus 15 centimeter. We need to find image distance v and height of the image h dash. Applying the lens formula, since 1 upon v minus 1 upon u is equal to 1 upon f, or 1 upon v is equal to 1 upon u plus 1 upon f, putting the given value in 1 upon v is equal to 1 upon minus 15 plus 1 upon 10 is equal to minus 1 upon 15 plus 1 upon 10. Now 1 upon v is equal to minus 2 plus 3 upon 30 is equal to 1 upon 30. Or v is equal to plus 30 centimeter. The positive sign of v shows that the image is formed at a distance of 30 centimeters on the other side of the optical center. The image is real and inverted. Magnification m is equal to h dash upon h equal to v upon u. or h dash is equal to hv upon u, height of the image, h dash is equal to 2.0 multiplied by plus 30 upon minus 15 is equal to minus 4 centimeter. Magnification, m is equal to v upon u, or m is equal to plus 30 centimeter upon minus 15 centimeter is equal to minus 2. The negative signs of m and h dash show that the image is inverted and real. It is formed below the principal axis. Thus, a real, inverted image, 4 centimeters tall, is formed at a distance of 30 centimeters on the other side of the lens. The image is 2 times enlarged. Power of a lens. The ability of a lens to converge or diverge light rays depends on its focal length. A convex lens of short focal length bends the light rays through large angles and focus closer to the optical center. A concave lens of very short focal length causes higher divergence than the one longer focal length. The degree of convergence or divergence of light rays by a lens is expressed as its power. The power of a lens, P, is defined as the reciprocal of its focal length, F. The SI unit of power of a lens is diopter, D. 1 diopter is the power of a lens whose focal length is 1 meter. The power of a convex lens is positive and that of a concave lens is negative. Opticians prescribe corrective lenses indicating their powers. It is more convenient to use powers instead of focal lengths. Example given. A lens of power plus 2.0 diopter has a focal length of plus 0.50 meter. The lens is convex. A lens of power minus 2.5 diopter has a focal length of minus 0.40 meter. The lens is concave. More to know. In many optical instruments, several lenses are combined to increase magnification and sharpness of the image. The net power, P, of the lenses placed in contact is the algebraic sum of the individual powers P1, P2, P3 as P is equal to P1 plus P2 plus P3 and so on. During eye testing, an optician puts several corrective lenses of known power inside the testing spectacles frame. Thus the required power of the lens is calculated by algebraic addition. Example, 2 lenses of power plus 2.0 diopter and plus 0.25 diopter is equivalent to a single lens of power plus 2.25 diopter. The simple additive property of the powers of lenses can be used to design lens systems to minimize certain defects in images produced by a single lens. Such a lens system is commonly used in the design of lenses of camera, microscopes and telescopes. Thanks for watching. Please like and subscribe my channel.